Welcome to solving trigonometric equations. Welcome to solving trigonometric equations part 2. So to solve these equations, you're going to need to rearrange each equation, and you make the trig function, so either sine, cos or tan, the subject. Then you solve the equation using your all stations to Crookwell. So for this video, we're going to look at when the trig function equals a negative ratio. So the first video looked at positive ratios and we went to the positive quadrant. When we do the negative ratio, we firstly draw the triangles in the correct quadrant. So that's the quadrants where the ratio is negative. So for example, if it's cos is negative in the second and third quadrant. Sine is negative in the third and fourth quadrant, and tan is negative in the second and fourth quadrant. So you draw your triangles in the quadrants that are correct for the ratio you're using. You then solve the trig using the positive ratio because we need an acute angle. So just change the negative to a positive and press shift sine or shift cos or shift tan. And finally, you place the angle in the triangles that you've drawn to solve for both the quadrants. So here's our two examples. We're going to solve for between 0 degrees and 360 degrees. So that's the all stations to Crookwell. We're going to solve 2 cos theta minus 1 equals 0 and 3 sine theta plus 2 equals to 0. We're going to go nearest degree. So for the first one, remember you're making the trig function the subject. So you've got to get the cos theta by itself and then solve. And the second one, you've got to get the sine theta by itself. Let's have a look at both. So here's our example. We're going to try and solve, or we're going to solve for cos theta equals negative 1/2 and sine theta equals negative 2/3. So the first one, 2 cos theta minus 1 equals 0. So we're going to add 1 to the other side. Then you're going to divide by 2 and you get cos theta equals 1/2. You then do theta equals cos minus 1/2 and you get theta equals to 60 degrees. So because cos was positive, because cos theta equaled 1/2 or positive 1/2, it's in the A and the C quadrant. So draw your triangles, put your 60 degrees in, and you get 60 degrees or 300 degrees as your solutions. So for the cos theta equals negative 1/2, draw your triangles in the correct quadrant. So that's quadrants 2 and 3 is where cos is negative. Solve as cos theta equals 1/2. So solve it as a positive so that we can get an acute angle. So you press cos minus 1 or shift cos of 1/2 and that gets you 60 degrees. Put your 60 degrees in your two triangles in quadrants 2 and 3, and then your ratio or your angle is equal to the distance or the angular distance from the positive x-axis. So the first one's 120 and the second one's 240. With the second one, once again, make sine theta the subject. So minus the 2, then divide by the 3. You get sine theta equals minus 2/3. Now when we solve this, we're going to solve it as a positive just so we can find the acute angle that we need to put in our triangles. So sine theta equals to 2/3. So you do the sine minus 1 of 2/3, that's 42 degrees. Put the 42 in our two triangles. Remember, sine was negative, so that's in the T quadrant and the C quadrant. Put the 42 into those triangles, and we get 222 degrees or 318 degrees. Thank you. So when we solve for sine theta equals minus 2/3, we pick the correct quadrants. So that's quadrants 3 and 4 is where sine is negative. We solve sine theta equals to 2/3, so we solve it as a positive. And shift sine of 2/3 or sine minus 1 of 2/3 is 42 degrees to the nearest degree. Put it into our two quadrants, into our two triangles, and calculate the angular distance from the positive x-axis. So the first one is 180 plus the 42, which is 222 degrees. And the second one is 360 minus 42 degrees, which is 318 degrees. Thank you.